Let's get started, actually. Right? Are you all excited about this session?
Yes.
That's why you're here, right? Actually, this session is unique. Unique in the sense that if I don't see many people in the room, it's kind of exciting. That means the container deployment is not an issue because people have figured it all out. So it's good to not have many people in the room.
Or
people don't have interest. No, they all have interest in containers. Everybody wants container, and people are figuring out in this room how many have you deployed containers already up and running in production. You should be here as presenting, not us.
would you like the mic now?
Ours don't work.
Okay, well then.
All right. So we'll go with the introductions. My name is Kishore. I work for Dell in PowerEdge Product Management Group. PowerEdge is our server line of groups. My focus is on software-defined storage. For planning software-defined storage, PowerEdge for that, right? And I also have focus on blockchain with emerging technologies. If anybody in the room is interested in blockchain, I'm keen on getting your thoughts on it after the session. So please send me an email. My email address is on this. Prior to Dell, I worked for Raytheon, VeriSign, Lockheed Martin, sometimes in the missile defense. Actually, some of my time was real core in the missile defense and the sensor systems and radar systems. But most relevant to today's discussion, I was director of IT at Lockheed Martin. So I applied a lot of that experience in putting this together with help of Brian. Brian, you want to introduce yourself?
Sure. My name is Brian Gardner. I work at SUSE. I've been working here for about 6 years now. I work on our alliances team as a technology strategist, which is a fancy way of saying like a solution architect. I spend lots of time doing reference architectures and things like that, white papers, reference configs. I work with hardware partners, software partners, embedded partners, so kind of across the gamut, which is awesome. I get to see that whole ecosystem, set of ecosystems and whatnot. And I didn't put it up here on my past, but my background is with one of the other hardware partners that we have. I worked there for 28 years. I was a EE for a decade. I did IT for a decade, and then I did software, Linux enablement of hardware platforms for a decade. So been around for quite a long time, and you know, I can resonate with Kishore about the IT side, and that's kind of what this presentation is about, is actually how you do a container as a service platform deployment, and what are the considerations that you really need to take into account.
So the agenda for today's session is pretty simple. How do you deploy systematically containers in your shop, in your data center? We're going to cover some of the how do you start with the proof of concept, going to the pretty much crawl, walk, and run phase, taking it all the way to the production. So, overview. Want to go start?
Sure. So, you know, we asked that question, kind of the feeder question, how many people have deployed containers and whatnot. But when you look at, you know, the classic mode 1 versus mode 2, right? There's the old way of doing things, and there's the shiny object way of doing things, which is the container way. So for those of you that are maybe not as familiar with containers and whatnot, the whole point of that is to have a microservice, basically a single process that's running in an executable environment that you can throw across multiple systems, right? As many as you want. You can scale up, scale down, do all that kind of good stuff. So if you think in terms of a process, that could be a microservice that's running in a container. That's akin to a process that could be running in a VM on top of a hypervisor, or you could run that process on bare metal, right? So you can do any of those things, but when you move to mode 2, which is the far right-hand column where the cloud containers microservices is, what you find is you can do a more agile deployment. You can do the DevOps approach. You can do things like if you truly go down the cloud native path, right? The end of the day story is everything's an API to you. Whether I'm talking to the microphone, that's an API. Whether I'm talking to the projector, whether I'm talking to a PowerEdge server, whether I'm talking to whatever, those are just APIs, and that's all I care about, and that's how I write stuff. That's cloud native. Okay? And really, that's what it's about. You know, you can accelerate, because when you have a set of coordinating microservices, I can focus on changing one microservice, making sure that the API is still compatible with the way I need it, and it can link up to those other services, and you as a developer can work on that other service, and you as a developer can work on that other service. And so I can focus on, and I can tweak, and I can change, and I can rev APIs, and I can make sure that there's backward compatibility, so version 1 is there, version 2 is there. And when you catch up with me, cool, you can use just version 2, and my version 1 stuff can go away. That's awesome. That's how you do cloud native, and that's really that right-hand side, that's the hard step, is taking a legacy application that may be monolithic and breaking it up into microservices and coordinating APIs and things like that. So that is a hard project, and we're not going to spend a lot of time talking about that until the very end, when we realize that once you have a container as a service platform in place, that may be one of the things that you want to address, and you want to tear apart an application or modernize it in some way, shape, or form. This just kind of shows you from an industry, you know, if you look at the market itself, growing by 5x in 5 years. So, you know, if we would have asked this question about how many people have deployed in containers before, maybe last year, we would have had less than half of you answer that way.
Huge
and even
scale.
if they're not working right now,
They're working.
So this is what enterprises have. This is kind of the reason, the rationale behind why this is an important thing to do. You know, there's about a quarter running today, planning going forward nearly half, and then within 2 years more, they're going to add another 17% of those folks.
That's actually,
Go ahead, Kishore.
I was going to say that this 27% by the raise of the hand today in this session, you kind of beat that number.
Yeah, you did.
Because we had more than 27% raise of hands when we asked how many of you are running in the production.
And I think that's because this came from 2017, so see, you're already in the 44%
Totally. There
place.
you go. Yeah.
Good.
Yeah.
Okay. So once you go down this path, one of the things you'll understand is that there is complexity with regards to having a container as a service platform, how you want to orchestrate things, how you want to schedule containers running places, how you want to do service discovery, how do you want to make sure that all of these, remember, we broke up an application, or you have n number of these services running together as API. How do you discover where those are running? How do they discover where each other's running? And then you also have the questions about, you know, how do you scale, which we'll talk about a little bit more, but some of the orchestration pieces kind of really help you in this regard with scaling, load balancing, being self-healing, and also giving you that monitoring capability. But when you talk about maintenance, okay, now I've got a platform that's hosting 1,000 containers on it. You know, if something breaks, how do I roll back? How do I recover? How do I make sure that, you know, updates don't kill me, right? So those are all considerations that we're going to talk to over the course of rolling out from that crawl, walk, run phase. Simple product plug, SUSE CaaS Platform. It is, so how many of you are familiar with Kubernetes? Okay, does that mean that you know what it is, or you actually are using it?
We use it.
Okay. So Kubernetes is the orchestration layer, right, that has become the de facto standard for most container deployments, right? That's the way that you can leverage a lot of those things I talked about on that last slide. Granted, there is a bit of complexity with Kubernetes, deploying it on your own. How many of you tried to deploy it directly from upstream? How'd that go? Okay, that's exactly what I would have expected. And there are, you know, kind of easy ways to kind of test a functionality, like with Minikube or something like that, right? There's ways to kind of get your foot into it and go, okay, I see what the advantages might be there, but then how do you get an enterprise version of Kubernetes running in your environment? That's what CaaS Platform really tries to deliver. And again, you know, because both of us have an IT background and both of us care very much about the deployment aspect, I just kind of wanted to show that it's a very simple set of steps to deploy CaaS Platform, right? Basically, right now, there's an admin node. You just set that up. You install an OS on any of the cluster nodes. You basically go to the web interface on the admin node and you say, okay, let's bring all those nodes into the cluster. And node 1, you're going to be a master. Node 2 and 3, you're going to be worker nodes. And that's literally all it takes to bootstrap a cluster. This process can happen in less than an hour. Okay? And now you have a full-blown Kubernetes cluster up and running. All right?
And those nodes Brian was talking about, they need to run on some physical servers. And so Dell's got, and believe me, this is the only marketing slide if you were wondering. So we got a slew of the big portfolio of PowerEdge servers, which is catering towards the needs you have. So we got from modular MX systems to rack-based system, Intel-based servers, and AMD-based servers. So in 1U, 2U, 4U form factors, sockets, single socket, 2 socket, 4 sockets for workloads like HANA. We got AMD, 1U and 2U, and modular. So let's get started actually now. So what is the pillars of this deployment of the containers? We're going to be pulling into system being the server. You need network, storage, software, and some sort of an automation as you go into production, especially when you have a cluster of nodes and you need to automate those instead of having to go to manually to each of those nodes to configure. So we're going to be talking about all these pillars through this crawl, walk, run stages and figuring out what pillars are important during the stage you are. Right? So we'll be discussing all that. So that is to set the stage. Make sense? Yes? Okay. So let's start with proof of concept. So I ask, or my developers used to ask when I was director of IT at Lockheed, and say, well, this thing is shiny new thing. I want to develop something for it, but how do I make sure to get this thing tested? And this is just a proof of concept. I just want to create a small little thing where I can just create something and develop and test it. So I asked that question to Brian, and Brian said, okay, let's do the crawl stage. So Brian, how do I do that?
Yep. So what I would do is basically set up what I call a solution admin host, which is basically just an OS running on top of a Dell PowerEdge box or something like that. Set it up as KVM, and then I'm going to spin up those nodes that I talked about a minute ago in the deployment flowchart as VMs on top of that. Okay, and now, much like I mentioned earlier, with you could do Minikube, which is a single node running a Kubernetes environment. Now I have a set of nodes that's running a Kubernetes environment that you can query remotely, and it's all very easy to set up. And I've kind of walked away from, okay, we're going to focus on when we talk to the developer. I'm going to say, can we just do stateless containers for now? And they're going to go, yes, because that's what cloud native is. I'm going to follow 12-factor to the point, right? And you go, cool. So I only have to set up a set of VMs for you in a solution admin host. And those are just VMs that are just sitting there. And basically, most of the communication between those nodes is going to take place internally, right? Open vSwitch, things like that. And then we'll go on to the next stage and start doing the consideration. So the IT guy is going to step back and go, yeah, I can do this. All right, now how do I do this? Okay.
So in this case, Brian said, well, all you need is, 4 nodes. I said, so I need 4 servers? He said, no. I'm talking about 4 virtual nodes running on single server. So what he's asking me was to do, and now I'm going back to my PowerEdge servers, like, okay, all you want me to do is give you one PowerEdge server, which is capable of multiple virtual machine hosts running, and that's where you will run containers. And he says, exactly right. So I configured a PowerEdge server which make usable for that virtual environment. So I looked at my databases and said, well, what kind of servers are on average, what is the configuration of a typical server in virtual environment where you're going to run 4 virtual machines, where you're going to run containers inside. So we come up with a configuration. You do need a little bit of CPU because you would run multiple virtual machines, a bit more memory compared to not running just the virtual machines on it if you were just to run containers. We're going to talk about that in the next phase. And then I pulled some drives. So this was interesting. That's where we had a debate between me and Brian. I said, well, I want you to use my boot BOS, which stands for boot optimized storage system. Geez, thanks, Kiran. I said that BOS word like since we released 14G for like bazillion times, but never said the full acronym. But BOS is what that's. So Brian said, well, why can't I use BOS to put virtual machines also on them? And I said, no, it's boot optimized storage system. Well, one thing is for sure, we test BOS for boot operating system. We don't test it for anything other than that. So that's a supportability question, right? But at the same time, you will be loading some virtual machines also. So I would rather want you to use a separate storage system, keep the boot separated with your virtual machine. So that's why I chose 250 gig on a RAID 1 drive for the storage, and then BOS for, of course, your boot system. Were you happy with that, or were you still having issues with me picking those two different storage systems?
So I'm totally happy with that. Initially, I kind of pushed back, like he said. And I said, well, okay, when I do the install, I've got to do the partitioning different. But once he did that, now it's very easy to put all the virtual machines and the images and everything on that second set of drives and optimize and use the BOS stuff for the OS. So I'm okay with that. I mean, it literally was changing answers in one dialogue during the install. But now we have a concerted idea.
Very cool. And in some of the settings on the server, we by default BIOS setting in the server will be enabling virtualization technology because it's going to be putting 4 VMs on it. What that does is the motherboard has a special function called IOMMU, which exposes the hardware directly to the virtual machine if you enable virtual technology. So it helps in virtualizing the hardware if you enable that. But if you're a latency sensitive workload, you're going to put it on it. There is a different recommendation to disable it. But just would want you to keep that enabled for this particular crawl space. Make sense? So that, then so we're going by that pillar. Remember the first slide, we had server, network, and the different pillars. So in the network consideration, even though it's a single machine, we did need some network to do the management and Kubernetes connection. So we chose our RNDC. RNDC is our network daughter card, so it doesn't require a PCI slot if it's on. Quad port, so that you can do the bonding. It helps, especially when you go in a run phase and walk phases. Some of the services you want to talk about, the NTP and DNS?
Yeah, so with clustered systems in general, you want to make sure that you have time synchronization, right? So NTP is very important, so make sure that that's an external source that you can point all of these VMs to, not just necessarily to them internally and point to each other, because then they can all drift, right? So point them all to an external one. I assume that even he might have put that on the switch for all I know. I don't care where he puts it as long as he tells me where it's at. Domain name services is another thing. You want to make sure that you have fully qualified domain names and things like that. You can use DHP, you could use MAC reservations and whatnot, but have domain name services set up for the cluster nodes. And you'll see why later on we're going to need this specifically. And as an IT guy, I'm already thinking, Mr. Developer, you asked me to do this, but I know you're going to end up asking me for more later, so I'm going to think a little bit ahead. I want to be able to do updates to the underlying thing, because from a security standpoint, we need to make sure that those are visible. So I can either point this solution admin hose at the customer center for SUSE and get the updates, or I can set up what's called a subscription management tool, which is it can be a VM, it can be a physical host, but basically it's a proxy for the SCC locally within the environment, so I can go get my updates from there. And the other thing that I'm thinking, trying to think again ahead of is, I bet at some point this cluster is going to need to expand, and I'm going to need higher availability and whatnot. So I'm going to set up a load balancer. Even though right now I'm only going to have one Kubernetes master node, and that's all I'm going to configure in there, but that gives me the ability to later add masters and scale it out and have resiliency and high availability. So I'm going to do that now.
So in this, because we are at the crawl phase, so we didn't need the other pillars of our so storage, because it's a stateless container, so we're not really looking into any kind of storage per se. So you're going to be, these pillars are less relevant, and there's no automation. It's a single server. You do whatever you want to do on the set server. So that's why we are not covering at the crawl phase the other pillars of that deployment. So what are we accomplished at the crawl phase, Brian?
So we're good, because now I can say, Mr. Developer, go install kubectl on your system, whatever you have, that a client, wherever, whether it's a Windows, Mac, Linux box, I don't care. And you can download the configuration file that points to this cluster, and you can start querying the cluster. You can get cluster info. You can check on etcd, which we'll talk about later. You can look at the nodes, and you can also create a pod, which is basically the single granular unit that you use in Kubernetes to deploy a container inside of, and you can delete them. So now they can play all they want. And what I'm going to start looking at is some of the base monitoring that's left in, so I can start to see at a node level how much usage they're starting to acquire. So I can start to sense when they're going to come back to me and say, yeah, can you up the capacity, can you do whatever? But that's where we're at.
Cool, so you nailed it. So my developers nailed it. I nailed it for the crawl phase, so I feel comfortable now. So now we go into, okay, well, let's extrapolate out this thing, and we walk into the walk phase. So our walk phase is, okay, well, as I just said, it seems to be working. I'm excited. Tell me now, what do I do next? So we are walking into a deployment, which is extrapolation.
And this is one of the cool things about a Kubernetes cluster, because inherently there's a lot of resiliency. And with SUSE CaaS Platform, it's pretty easy to add, subtract nodes, and do things like this. So I'm going to go back to Kishore in a second and ask, can I get some more physical nodes, right? I'm going to do something outside my solution admin host to add bigger nodes that have more resources, because now this whole room of guys on this side are developing and putting containers out there. So that VM stuff that I had, I could grow it in VMs too, but I'm going to start growing towards the physical space to accommodate all of those guys.
Okay. So, you know, somebody says, and not me, it's not an official statement from Dell or me either, but somebody said, well, container, you said in the crawl phase, virtual machine, aren't these the competing technologies? Why are you mixing it up? Okay, well, we won't. So here, in this phase, we go, well, every node has containers only, no virtual machines. So our server consideration, of course, changed to suit to the containers only, right? So we chose a lesser memory per node, but you're looking for more than 12 nodes now, because you're in a walk phase, and there are many people interested in putting it together and testing it. So you got more than 12 servers you're going to be putting in, running on R650, lesser memory, storage, and BOSS. Okay, so here's the thing, right? So I did not put BOSS here. The other way around is not true. In other words, what I said earlier, that you don't use BOSS for anything other than operating system. That is still true. So here I'm saying, if you did not bring BOSS in your server for this walk phase, you can use the storage for booting, because you're not going to be putting virtual machine. You're just going to, the containers are still stateless, so you install operating system and like the micro OS and containers, but you can do that on the storage itself, or put BOSS. It's your choice. But again, the statement stays true. Once again, do not use BOSS for anything other than operating system. So that's the criteria we use for picking this server, 1U2 socket. It's got 3 PCI slots. I used this server. It has 3 still, because we are using Rec NDC, so we still have 3 PCI slots open for your future, because now we are 12 of you or multiple developers working on it, even though you don't need those slots today for GPUs. But as Brian said, they are developers, and they want to keep testing stuff on it, and tomorrow they might want to put an extraneous workload on it, which requires GPU. So you may want to throw in. You have empty slots to put GPUs in it, and test out those for your container workspace. So that's the reason we still have a 10 gig quad port, which you would bond between. So another thing about bonding is, well, not so much here. Well, they are single quad port, so you bond these two and you get a redundant network, right? But one thing I want to point out is that try to distribute among multiple racks for obvious like power failure. If it were to happen in one rack, you're not down completely. These pillars are still, these containers still stateless in our walk phase. So these pillars are not relevant to this discussion at the walk phase. Okay, so what did we, oh, then there's a software consideration.
Yep.
So
So remember I mentioned earlier we're going to do the HA proxy, right? We're still going to keep that intact because I know that the next stage, if we get there, so if our developers are happy enough and they want to move forward and stuff, we're going to need this. So I want to make sure to call that out again. And if you look up in the top right there, that's what HA proxy looks like. Basically, there's a couple of ports that you need to make publicly visible for the master. There's one that's basically the authentication piece to get that download of that configuration file, and then there's the generic API that you're talking to Kubernetes with, okay? So you want to make sure both those ports are there. And, again, that side of the room, those are all developers over there. That one guy, we set up one user and gave him kind of like full admin rights to the cluster, so he could do whatever he needed to. But now we're going to go, no. I'm only going to give you these kinds of access rights, and you only these kind, and you in the back in the corner. I'll let you launch containers, and we'll call that good, okay? So you can set up all of those as individual users, give them access control, and very granular fashion, you can say what they can do and what they can't do. Monitoring, again, what you'll do as an IT person, you'll probably spin up a little bit more. There's things called Helm charts, which are basically ways to deploy multiple services at the same time. You can do that, and now we can start to do more granular monitoring. And I know it's a little bit hard to read down there, but I can list out the containers and the virtual CPU that they're using, the virtual RAM using. So now I can start to sense how much of a container workload is on these physical hosts. Okay?
So what we have accomplished now?
So now we've got a pretty good cluster, right? And I'm going to put a caveat to this drawing here. One of the things that Kishore and I talked about yesterday was the notion of, you remember how we did everything on that solution admin host and we had those VMs set up and whatnot? In this picture, I portrayed you could move the entire cluster outside to physical nodes if you wanted to. Okay, you can do that because the web interface, which is called Vellum, that's for SUSE CaaS Platform, literally you spin up another node, you install the OS, you add it into the cluster, and you say you're a worker or you're a master or whatever. You can, and then you can throw away old ones too. You can delete, just the opposite path. But what we would suggest doing on the solution admin host is kind of leaving those VMs sitting around, because from an IT perspective, we might want to move those nodes, label them differently, play with it, and do functional testing and API testing just to make sure that the cluster is healthy outside of the worker nodes that those guys are using all the time. And you can also start to have some other processes and whatnot show up there. But what we've accomplished is, again, you've got command line access from the remote systems. You can spin up and spin down containers. We've given you granular access, and that's a function of how your organization is set up and what each of the developers' roles are and whatnot. But we can continue to add these nodes.
So, I feel comfortable now. I feel that, yeah, I played enough. With 12 nodes, the access control is known, the capability of the servers, nodes is known, and now I'm ready to take the plunge and to go put this container in a production run. So we run into the full production instance of the run. So the goal here is, okay, well, can I really make this container in my production? So a cluster of containers and then at that point, it won't be a stateless containers because I would need storage. So the production environment, things will become real time. The company will depend on me on some of the workloads that are going to run on those. So I had made sure all my learning from my crawl and walk stages, now I'm going to use that learning towards my run phase, right? So with that, we went into so all those pillars are now relevant. SUSE Enterprise Storage, which runs on Ceph, could become my state. Well, I'd say could become.
It did.
It did.
And that would be the choice that we would use.
This
Yeah.
is the choice we made, at least for this, right? So we want to talk about SUSE Enterprise
Sure.
Storage.
So again, as Kishore mentioned, it is Ceph-based. It has the ability to do pretty much a horizontal scale as far as you want to go, right? We know of 1,000 node clusters that are in production out there, and they just keep scaling the storage nodes out on a very regular basis. And what's really interesting is the performance goes up every time they add nodes. Okay, so it's very contrary to normal storage technologies. And you know, the model we have, and you can kind of see a little picture in the middle there, is that we have a subscription that's a great starter point, and Kishore is going to go over this a little bit more here in a minute too, that has, you know, a base level of storage nodes that you need. It has the monitor functions, it has the ability to add gateways and whatnot, and it also has, right now, an admin node that you need, very much like CaaS Platform did. So that's what SUSE Enterprise Storage is in a nutshell. And Kubernetes already knows how to talk to Ceph via RBD, which is a Rados block device. Okay.
Yeah, very cool. I actually, I want to make sure that we understood why did we need SaaS or a storage, right? Because now we're going to production, the containers are no more stateless, so we needed a storage in the background. So that's why we introduced storage pillar, and we are talking about storage. So that should be very clear. So for this, because now we are in a production and containers, we got a cluster of container nodes, so it could be as many as 150 physical servers. I guess 150 is the limitation from...
Yeah, that's a limitation that we're kind of imposing for our customers because that's the biggest cluster we scaled and tested, whatnot. Kubernetes does not have that inherent limit right now, and going forward, that limit will disappear and dissipate for us too.
Right.
But that's where we want to kind of focus, because at that point you want to consider maybe having multiple clusters instead.
Right.
Okay.
But as far as the container nodes are concerned, you could use those walk nodes configuration for container nodes. The configuration here is for storage nodes. So I think it's kind of not very clear on them. We could have done a better job in describing it here, but I want to make sure that the first line refers to the container nodes, which you could use the similar configuration what we used during the walk phase. The configuration here is for the SUSE Enterprise Server, the Ceph configuration we were talking about. So we are saying that you would want, because the Ceph, Ceph doesn't have any limits of how many OSD nodes you can use, right? So basically, let's say if you decide to create a Ceph cluster made of 1,000 servers, which will be, I love that. Call me. I'll engage Kiran. But if you did that, we would want you to use our two-socket server. R740XD is the but in terms of our configuration, we would want you to use high-end CPU, a little bit more memory, and of course BOS because you are going in the storage RAID 1. And so this is a minimum server topology for Ceph deployment using SaaS, right? So a minimum you need 4 OSD nodes. They're all R740XD. We got...
and Kishore,
yeah.
Anybody know why we would suggest 4 as a default number of nodes for the minimum? So the default replica count in Ceph is 3, right? And with this data, there's 3 copies of the data spread across the cluster. With 4 nodes, I can lose 1 node and you still don't lose any of your replicas, right? Because it can shift and move things around. So that's why we suggest 4. That's how that number came up. Go ahead, Kishore.
Cool. And at minimum, you need 3 monitor nodes. Of course, for obvious reasons, you need monitor nodes to be there. In case there's one goes down or two goes down, there you always
Classic
have
HA, right?
HA.
You know, you always want to have an odd number so you can have
Yeah.
a quorum and you can have those two fight it
Right,
out.
actually that's a good point, because as you increase number of OSD nodes, we would say that you need to increase monitor nodes too, and always add them in pair, so you always have a witness in the odd number monitor nodes. Then you have minimum of one solution admin host where you would host things like DNS, DHCP, and TP. We recommend that put those, especially NTP, not in a virtualized. So even though SAH, you can do a lot of services like these in virtualized KVM virtualization, but keep NTP on the OS directly.
And remember,
what's
it's
the
a
word?
cluster. NTP is important.
Yeah, NTP is important, especially when you connect to NTP. And then we have a public/gateway client node. From container perspective, if you were to put this storage for other services like S3 gateways or NFS or
iSCSI
is it
or
okay to say
SMB.
NFS? I
Yeah,
know
of
you
course.
guys don't like me saying NFS.
No, NFS works.
it
We
works.
support that.
Yeah. Okay.
And so does Kubernetes. It knows how to bolt into NFS too
So
if you want to go down.
For that,
but-
so you got an RADOS gateway here, which allows you to connect to many of those other storage services, which this can be used. Of course, RBD is built into, so you don't need a gateway for that. And we got two networks going on here. There's a private network between OSD nodes, and then there's a public network connecting to other monitor nodes and gateway nodes, and of course container nodes, right? So there is a network consideration to that now. So here I chose dual port 25 gig network for both private and public network, even though public network traffic isn't going to be as much, the bandwidth requirement won't be that much, the throughput isn't also needed so much, but for the private network, which is the network between the storage nodes, it's going to be a lot of replication between the nodes of the data. So there's going to be a lot of throughput needed and hence latency. But we chose the same network to minimize the latency difference between public and private network. And I tell you why. The timing is critical in this. Even a latency difference of microsecond can make huge difference in the entire cluster, especially if you're a cluster of 1,000 nodes. A microsecond latency difference between monitor node and the OSD nodes can cause huge problems in your cluster. So we recommend that you use the same, at least minimize that latency as much as possible, to the extent that when you're configuring your server, so I'll tell you something about Dell. We have a thing called CFI. It's called Custom Factory Integration. There are certain things you can ask CFI to do for you. It's kind of a second touch, so it will go from factory to another. The reason I'm talking about CFI is when you put a PCI card, because in this case you are putting a PCI adapter in one of the slots of the server. The first is RNDC, second is PCI. You could be putting this in a one specific slot number 2, which connects you directly to the PCI bus to the CPU to reduce because you put everything in the same NUMA, it reduces the latency from that card to the CPU versus that RNDC, which is already on the is a network error card. So to that extent, I'm sensitive that you should be careful about this latency difference. It's very critical, especially I have no issue when I put it in my lab because I had 4 servers. There was hardly any, but if you imagine the production run, you got 1,000 servers, this becomes a bit more issue, and that's where you recognize, oh, what's happening. So be careful. Make sense? Right. So then we chose our Dell networking switch, which supports 25 gig networking. And of course, I said that during the walk phase also, that distribute your servers among the racks and switches. Obvious reasons.
Yeah, and also, we have these pair of network cards and whatnot.
Oh, yeah.
As you do bonding,
Good point.
just from an HA and kind of reduce single points of failure, when I do a bond, I'll probably do it on port 1 across 2 cards. So if one card fails, it doesn't wipe out an entire bond, right?
Yeah, so the bonding, did you also say about bond RNDC's one port with PCI adapters one port? Did you say that?
Yeah.
Okay, well, I'm sorry,
Yeah.
I missed that, yeah.
Yeah.
So, right, so what's the software consideration?
So again, on the very first slide, obviously the CIO probably has come to us and go, okay, we're going to move this into production. I want to make sure the security updates are taken care of, right? And that's what that flashing animated GIF is doing there. It shows how, from a admin perspective, basically they get notified that updates are available. And now we're talking about updating a 150 node cluster or some big number of containers, right? Container hosts. So it'll get the update and it'll basically say you need to update the admin node first. So that's node 1. It'll go through, do the update, it'll do the reboot, right? And during the reboot, obviously I can't tweak the cluster, but the cluster is still totally functional, right? Then what happens, it'll say, are you ready to do the rest of the nodes? And it'll literally walk through the nodes one by one. It basically does, if you look at a lower level from Kubernetes perspective, it cordons it off so that no more containers get scheduled there. It drains the containers off, applies the updates, and because we have micro OS, which is snapshot based, it's based on ButterFS, we actually apply the updates into a snapshot, and then when you reboot the node, you land on that snapshot, comes back up, make sure that it's part of the cluster, and then it uncordons the node, and then you just do that 149 more times. And it does that all for you. So it's kind of almost like a rolling release underneath this platform, and that's because the above stuff, the container stuff, the Kubernetes allows that. It gives you that resiliency, right? Because when you say I'm going to spin up 3 Nginx containers and I want to do a replica set of 3, Kubernetes will make sure there's always 3 running. And even though I take a node down, and one of the containers goes away, Kubernetes says, oh, let me fix that, spins up another one somewhere else. Okay, so you rely on this inherent resiliency of the entire infrastructure. What you'll probably do too is, these were my hardcore developers that are the kubectl guys, and then they've hired a bunch more people to help them do more containers and whatnot. And those guys go, where's the GUI? How do I fix? Well, you can obviously put a Kubernetes dashboard up there as well. So now they can see the infrastructure itself. They can see a catalog of containers. They can deploy it. They can say, spin up 3 of those, do this, whatever, right? And that may be when you start to pull in more of your QA and other parts of your DevOps. And then also, lower right corner, there's also a management dashboard that's on top of SUSE Enterprise Storage that gives you the performance information, gives you the ability to manipulate pools, placement groups, all those kinds of technologies that you need underneath, so that you can add them to make them visible to certain namespaces if you wanted to in Kubernetes and whatnot. But you can manipulate that at the command line level or via the dashboard. So now we've kind of given you a complete system that it has scaled. We have the ability to have storage for those stateful containers, and also now for logging and monitoring, right? So all of those logs that you're generating with all those containers, you can throw that on the SUSE Enterprise Storage backend. All that monitoring data that you can collect, you can put it back there too. Okay, so now you're using it from an IT perspective along with those stateful containers that might be a database or something. Okay?
Yeah, makes sense. Now we got 1,000 storage nodes, OSDs, and about 150 container nodes. And when you're going into the deployment, going to each of those nodes and configuring for them is kind of a very Herculean task. If not, maybe Herculean is a little bit.
You don't want to type something 150 times?
Yeah, I could go each one. I could.
You'll never make a mistake.
But the good news, good news is we do have help there. So we have a systems management tools available to do a lot of automation for this deployment. So you can create things like you need to do right boot order so that it boots from a BOS, or you want to boot from Pixie boot, power management, OS provisioning. Right. So to do all those automation on all those 1,000+ nodes, you could use our iDRAX, which has CPs, we call it, server configuration profile. That requires that you install OpenManage Ansible modules and libraries, and it's SCPs. You share it over one of the servers using an NFS share. It's the mechanism how do you use SCP, and then you create your own script. So if you want to do, let's say, 2 different SCP for OSD modules, OSD nodes, and say controller node, you can do that and use your script to do SCP1, SCP2. So those kind of scripts, and GitHub has some guidelines to do those SCP. I wish we could have done one of those scripts, and Brian and I were talking about that we should do one of those maybe in next session sometime. But that's what I have today. At least you should know that this is for your automation. For switch, because especially in the production run, you will have multiple switches over multiple racks. So there is a good news there too. We can configure your switches consistently using the containers itself. You put that container in one of the server nodes, maybe in SAH, and use the Docker and build the Ansible. So those are the commands over there to configure your switch. Additional APIs are available on our OpenManage Enterprise and Redfish scripting, and the links are there to share with you what OpenManage APIs looks like. You got all groups, devices, inventory. You can get all those managed inventory of the devices. So this is commands available to you. And for other iDRAC Redfish scripting, what you can do is you can do a lot of things like BIOS operation and iDRAC operations, firmware operations, server operations, right? So all those things can be done using those Redfish scripting, right? And but you need some prerequisite. So you need that to a minimum, I would say 14G. Although we say even if you have 12G servers, which anybody has 12G servers, you do. Upgrade them to 14G. But you need a minimum firmware version and iDRAC version. Right? And and we also have an SDK on OpenManage, so which has a Python library for lifecycle management of PowerEdge servers. It's got iDRAC REST APIs in it, and it leverages those, and it has Redfish standard WSMan and SNMP. So a lot of help available to you to do this automation. So don't hire that college grad you were thinking who will go to 1,000 nodes. He will still make mistake. Right? The automation is the key. So where are we now on the production side?
So now you can see that we have a full-blown container cluster, which is these set of columns. We have a full-blown Ceph, SUSE Enterprise Storage, which is that columns. And you can see that there's ellipses. You can grow any of those anytime you want. So you can scale capacity-wise, performance-wise, whatever you want. You will notice there's lots of networks labeled up here. Some of those can be coincident, okay? But I wanted to call them out separately so you could see in a vision world which ones are public. If you look over at the right-hand side, the ones with the arrows, those are actually the routable ones. The other ones are internal, okay? So there's lots of them, and they could be done with VLAN. So don't think that you have to have n number of network interfaces, right? You can, just as Kishore provided, we can put all of that on those network interfaces he specified. We have those core services that we really care about, right? And that load balancer. Now, because we have multiple masters behind it, now one of those masters can go down anytime, and because of that security update process, it can just happen. Nobody will ever know that it went away, right? And it'll come back up, and HA proxy will be sitting there and notice, oh, it's come back up, so I can vary requests to it. And then, this is very important, especially now for all of these automation tasks, right? That's how we're going to talk to these hardware before they are a known entity to us. Right?
Yeah. Okay. What, does anybody know what iDRAC stands for? If there is any Dell people in the room, they shouldn't raise their hand. Right. Yeah. Okay, Dell people.
Dell Remote Access Card.
Who said that?
Dan.
What's I for? I don't even know that, but it's integrated. Integrated.
Good.
Right.
I'm sorry. So Ceph, is that all RBD and the gateway is the NFS gateway?
So, yeah, Kubernetes speaks RBD, so you can just use that.
It also speaks FF. Doesn't it speak SFFS too?
You can use NFS. I'm not sure about Ceph-FS.
Okay.
I
Yeah,
don't
you need
remember a
a-
Ceph-FS interface for Kubernetes.
I believe that you need RADOS for Ceph-FS.
Of course, we need RADOS for everything but Ceph, but so everything's RBD and then the gateway's NFS for client file sharing?
Yeah.
Is that the gateway?
No, that could be for anything, because remember, we're building a big storage cluster that could be multi-purpose and handing off storage to other things.
I saw NFS on the previous thing, so is that?
That was actually the NFS share for the automation piece, which could sit on the solution admin.
Yeah,
It's
that
just
can
a
sit
place
in-
to put the content.
Yeah, you meant this
This one.
NFS. Yeah.
That's just for those.
That's for automation. So the SCP, the way you provision SCP is through NFS share.
All right, so
That-
everything is Ceph is RBD.
This is Ceph RBD, yeah.
So all the clients are just getting block storage.
That's correct.
Yes.
Yes.
Okay.
Yep.
Yeah.
And they can be persistent or dynamic too.
Yeah. Yeah. Sorry about that, but that's a
So, good question.
call
Good
out.
eyes.
Yeah. Good call out.
So we took care of updates, right? We can manage the cluster over time. We can make sure that we're always keeping up to date with the container runtime engine, the Kubernetes, security updates, all that across that. And the Ceph cluster, the SUSE Enterprise Storage one, can also point to that same SMT device that I mentioned earlier, where that's a proxy for those updates so that you can do that. And again, because of redundancy and resiliency that's built into Ceph technologies, right, I can patch one of the OSD nodes, take it down. None of the clients are ever going to notice that node went down, and then bring it back up, and then walk through and do those two, okay? Same thing with monitors, because they're an HA configuration, right? There's 3 of them. One can go away. We can patch that whenever we need to. So we've got that redundancy. We've got scale out. You know, we can do the 150 nodes on the container side. We can do the thousands of nodes on the storage side, as much as you want, as much as he'll accept.
I'll take any number
And-
above 1,000.
And because we have that storage back in, now we have the access to do the monitoring, the logging, and also those stateful containers. And we have monitoring utilities both on the dashboard side for the SUSE, for the SUSE Enterprise Storage with what's called OpenAttic or the Ceph management dashboard now. And also, I didn't call it out, but you could have installed like Prometheus and Grafana on the container side. And so now you have a graphical user interface for all the monitoring that's happening there too. Okay.
Beautiful. So I love it. It's running in production, and my management is happy, and that we did fantastic job, and we're all containerized. Performance is great. Storage is running. Things are beautiful. So with that, how do you wrap it up?
So what you've seen, and this is a real value proposal, and this is something that we worked with Dell on because of solution architects and whatnot that came to us and told us that, you know, customers need to have an entry point, right? So having that crawl stage where they could deploy it as all VMs on a single node is a great way to introduce the concept to them. And then being able to migrate that cluster out to the 150 nodes, that's a good thing because they can scale up as they need to, right? And they can add physical nodes as they need to, things like that. And then of course, you know, from the storage backend, again, once they get to that mindset and they go, okay, I've read all the 12 factors, and oh yeah, there is something about logging and monitoring. Where am I going to put that stuff? Okay, we need that storage. And then somebody starts to tear apart a monolithic app and they have a stateful container, like a database, and they go, where am I going to have that volume? Where's that block device? Where am I going to store that information? Okay, we got you covered, all right? So next steps.
You want to do additional workloads, reconfigure those storage nodes heterogeneously, meaning some nodes have storage of all NVMe or fast performing, cost optimized storage, some NVMe, some rotating drives, cold archival nodes. So, but then the good news is with the Ceph and SaaS, we can bring this whole cluster in a big storage node, run multiple workloads, containerized, target to whichever workload needs whatever kind of storage performance.
Yep, so even like in the additional workloads, you know, remember Kishore up at the front mentioned he was thinking about blockchain. That could be a containerized application that's running on here.
Oh, yeah.
You could run analytics, because remember he said we left some PCI slots open so we could put GPUs. Okay, we can start doing containers as analytics workloads. There's all kinds of opportunities now, right? So you've opened up the floodgates, and you have a full production instance that you can run this stuff on.
Yeah, you open up the floodgates, but it's risk-free. You have gone through crawl, walk, run phase, so you figured it out all, so you're confident. Because when I was at Lockheed, anything I rolled out, I did not sleep after rolling it out for many, many nights. All the calls came in the night. 3 a.m. was my standard. That I told my wife that I won't sleep tonight because I'm going to have a call at 3 in the morning and it will come, right? So knowing that, it was very important that you did crawl, walk, run phase. You tested it, maintain that testing facility. So whatever crawl phase, so if you notice one thing is, during the crawl phase, whatever server configuration I used, I did not use the same during walk and run phase. And I did it on purpose because I didn't want to destroy that crawl phase server. I'm going to use it for continuing to, throughout the sustaining phase of this production run, because that's my test bed. So otherwise, what used to happen, even my personal experience, that my IT admin would take that server and say, well, I can now use it in the production, it's the same server. I'm like, no, keep it there. So it's on purpose, right? There are some references. The presentation is going to be made available to everybody. So you,
Talk about your presentation.
oh yeah, it's not important, but it is. I'm talking about tomorrow Ceph and SaaS and how do you deploy storage. This is a hands-on lab in my lab in Palmer South in Austin where we collaborated with SUSE and we did a testing of a deployment of Ceph and SaaS on our PowerEdge server. So this session is going to go in those details of the recommendation out of those testing. So it's very interesting. It's a good session. Please come join us.
And there's also a reference documentation, implementation that walks you through this entire thing with a cut and paste kind of, here's how you do the commands, here's how you do integration between CaaS Platform and SUSE Enterprise Storage. All that's documented for you. So.
Yep. Yeah. If you don't have any questions, it's okay because there is a cocktail hours today, 7 o'clock. You can take all the questions there versus in this room. But no, I'm kidding. Questions?
So, Kishore, you talked about latency in storage. Are you recommending consistency in the network infrastructure, so 25 gig or 10 gig, consistent between the NICs, the switches, both private and...
Well, that's one of the points. So you do want to keep things consistent among OSD nodes and the worker nodes, like container nodes. That's one thing for sure, and it helps in cost actually to a certain extent. But I was talking more about latency difference because if you have a latency difference between a MON node and the OSD node, that can result in a microsecond time difference. And then a Ceph software or your SaaS might have to do some corrective action and will start throwing error logs before it starts doing the corrective action, and it can throw the cluster. If that time difference increases, it has the potential to throw your cluster offline sometimes to protect the data. So that's the real technical reason, and it especially when you have multi-node cluster like 1,000+ nodes, this thing can actually become a big issue. So that's why I say that keep those consistent and on the similar latency as much as possible, same network card. 25 gig from Broadcom versus 25 gig from Intel, don't do that either. I'm that cautious, right? I'm very paranoid about this. Yeah, use the same network card interface on both and put them in the right slots on the server. So as I was saying, the CFI, actually I should have mentioned CFI from automation perspective also. There are many of those things you can order custom BIOS if you were to do, if you knew that what you're going to deploy and how you're going to deploy. our CFI can help you pre-configure those settings in the server through our custom factory integration. So I should have mentioned that too. But yeah, the slot I was saying earlier, is as important. If you put it in, because there is a daughter card and then there's a PCI card. So daughter card is on a different. You don't want them to be in a different NUMA domain of CPU. So make sure you are selecting the right PCI slot. Yeah. So I'm that sensitive. All right. Any other questions? All right. Well, thank you so much, and I appreciate you for listening to us.
Thank you all.
Thank you.